Number 4 and 5, we have some square root functions here, and let's go ahead and solve them. And then we even have an additional sentence. We got to check for extraneous solutions, because sometimes after we solve for x, it might not work. And then I can show you a graphical representation as to why that is. Let's start with number 4. X equals square root of 6 minus x. When you have the radical, the square root by itself, we're going to undo it. And to undo it, well, to undo a square root, you're going to square both sides. So in the previous part, to undo a square, you're going to square root both sides. Now it's going to be the opposite. To undo a square root, you're going to square both sides. So squaring meaning put it as an exponent of 2. Anyways, this is going to be x squared. Then these will clear out. It's going to be 6 minus x. It is a quadratic, and so you want to the process for that is you want all the terms over on one side. So I'm going to subtract 6 on both sides and at the same time add x on both sides. None of these 3 are like terms, so we're going to put them in descending order of exponents. X squared plus x minus 6 is equal to 0. This is very similar now into part 1, where we're going to have to factor this portion here. Factor. What two numbers multiply to -6 but add up to a 1? Let's see, I think it's going to be +3 and -2. Okay, from over here we're going to do ZPP. X plus 3 is equal to 0. X minus 2 is equal to 0. X equals -3 if you subtract 3 on both sides. And x is equal to 2 if you subtract 2 on both, add 2 on both sides. And actually, I should not have boxed them yet. I really should not have boxed them yet. Maybe I should wipe this part out over here, because we have to check. So these two are what's called maybe like your potential answers. So what's going to happen is we're going to have different scenarios. After we check, both of them could work. Or one of them could work. There's also a case where none of them are going to work, and we just got to check to make sure. So this has to be done, and I'll show you a graphical representation as to why that is. So let's start with the first one first. Let's start with -3, I guess. X equals -3, checking. So what you're going to do is you're going to go back to your original equation right over here, the one before you squared both sides, and then plug in the -3. So here and then here. Okay. So -3, 6 minus -3. And then I'm going to put a question mark here because we don't know if they're equal yet. So we're checking to make sure that they're equal. So that's why I'm putting that question mark there. Okay. So let's just now simplify it. Question mark, -3, question mark, is it equal? 6 minus -3 turns into positive. And then, because it's a positive square root, you're only taking the positive answer. So square root of 9 is just 3. Okay, are they equal to each other? They are not equal to each other. And so we're going to go back to the potential answers, and I'm going to X this out. So we shouldn't have boxed it in the first place. We got to check them first. So that doesn't work. Okay. Now let's go see the other scenario, the other potential answer, x equals 2. Let's see if that one checks out. X is equal to square root of 6 minus x. Let's plug in that 2 here and here. 2. And then again, question mark. We don't know if they're equal to each other, the left or the right. Okay. 2 is equal to, we don't know, 4. And then we take the positive square root because we take the positive square root because it's positive. Square root of 4 is 2. This checks out. So we are going to accept this answer and reject -3. Okay, so your only answer is x equals 2. And then I'm going to quickly show you on the TI-84 why this is. I might have to clear out a couple things, actually. Oh, no, I don't have to clear it out. Okay, so what I'm going to do, I've taught this a little bit in Algebra 2, where I broke it up into 2 different functions. If you can see that this is a line, this is equal to x. So I'm going to put x over here. So that's one function. I'm sorry, I guess it was a little bit too bright. And then on the second line, I'm going to put square root of 6 minus x. Square root of 6 minus x. So you're really seeing where they intersect, if they intersect at all. And I hope you guys can see that these are two different functions that you're equaling to each other, and you're trying to see where they meet up. Okay, I'll show you guys again. This zoom fit will be our best one over here, so 0. Well, let's see if it works. Let's see it. So that's the line x, and then now it's graphing square root of 6 minus x. And then let's take a look at the intersections over here. Calc intersect. It's going to ask us to kind of see where that is. So your only intersection is at 2. Okay, so that's why you're solving for x, because you're trying to see where it intersects. It intersects at x equals 2. And we don't see an intersection of x equals negative 3. X equals negative 3 is right over here. We don't see any intersections at all. So that's why we only have one answer, because there's only one intersection. This is why you've been solving for x this whole time, if you have not known why you're solving for x. Okay. All right, so hopefully that visual representation works out. Let's do number 5, and then I'll stop the video. We'll move on to the next. Okay. Again, the point of, we've done absolute values, we're doing the square roots, we're doing some other things. Really, the point of it all is when you have functions like these, you just want to isolate it. And so to isolate this, I'm going to have to subtract 11 on both sides. So I'm going to subtract 11 on both sides because it's positive. X minus 11 is equal to square root of 61 minus 6x. Okay, and I'm going to write this twice for notes purposes. Okay. Now that it's isolated, it kind of looks like number 4 now. Now that it's isolated, you're going to square both sides to undo the square root. Okay. Okay, so now you're just left with 61 minus 6x on this. All right. I want to remind you that x minus 11 squared, this is x minus 11 times x minus 11. We're going to have to multiply this one out. So we're going to have to multiply this out either FOIL or box method. I think I've shown FOIL the last time. And so what I want to show you guys is the box method over here. So here's another way to do this. X minus 11, x minus 11. It's really very similar to FOIL. It's just that you just got a box. Okay, x times x is x squared. X times negative 11, negative 11x. X times negative 11 is negative 11x. Negative 11 times negative 11 is positive 121. Okay. And then you're going to add like terms. So then your new left side is going to be x squared minus 22x plus 121. So that's another way you could multiply polynomials together like that. So like if you have two terms inside, you can do FOIL or box. Will come out to the same. We have quadratic. We're going to move everything on one side, minus 61, minus 61. And at the same time, I'm going to add 6x and add 6x. X squared, 22, negative 22 plus 6, negative 16, yeah. 1 minus 1 is 0, 60, positive 60 is equal to 0. Okay, all right, we're going to factor this portion here. What two numbers multiply to 60 but add up to negative 16? I hope you said negative 10 and negative 6. Okay. Then you're going to ZPP. X minus 10 is equal to 0. X minus 6 is equal to 0. So you have two potential answers, and I'm not going to box them. X equals 10 and x equals 6. Because we add 10 on both sides, we add 6 on both sides. Okay, we got to check. So let's go check this one out. I don't know why I clapped. Start with 10 first, and we're going to use the original equation that we used, 61 minus 6x. Okay, and then we're going to plug in the 10 here and here. So 10, and is that equal to whatever we're trying to do? 61 minus 6 times 10. 10, is that equal to 61 minus 60? 61 minus 60 is 1. It's already positive, a positive square root, so positive square root of 1 is going to be 1. 10 is equal to 12. No. So we're going to reject 10. Let's try 6 now. X equals 11 plus 61 minus 6x. Let's plug in the 6 over here. 6 equals, and we don't know it just yet, 61 minus 6. I'm going to multiply that by 6. 36. And then 61 minus 36. Ooh. 25? 6. Okay. It's positive square root of 25, so positive square root of 25 is just going to be 5. Oh no, 6 is equal to 16. I don't think so. So, when this happens, when both or all of your answers just do not work out because you've checked them, then this is the point in time that you're going to put no solution. So again, sometimes 2 of your answers work. So yeah, there are cases where both of them will work. There are cases like number 4 where one of them works, and I showed you why, because it only intersects at one point in time. And then there's cases like number 5 where none of them works because they don't intersect at all. And let's go actually check it. No solution means that they don't intersect. What does that mean? Well, I'm going to clear this off. Clear. Okay, so your first function on the left side is x, so we're just going to leave it like that. And then let's type this in, 11 plus square root of 61 minus 6x. Okay, zoom fit is going to be our best friend, and that's, we can just type in the 0. And then let's see what these functions will look like. Probably not a good, like, I'm going to change the window. So maybe I want a little bit more 16, 0. Let's take a look at that. Okay. Okay, so if you take a look, it's kind of close, but it does not intersect at all. It's like, I want to touch you, but I cannot, you know? So it doesn't touch, they're not intersecting at all. So this is why it is a no solution. Apologies, this video is a little bit longer than 10 minutes, and well, but I'll see you guys on the next video.